Hey guys, there was just one little thing that I wanted to talk about more, either because I didn't specify it enough or I forgot to mention it. But it's just a few little properties. I did want to talk about this corresponding parts of a triangle, and that's referring to the angles that are congruent to each other, as well as the sides. So if we have this triangle right here, and I'm saying that angle A is congruent to angle E, and angle B is congruent to angle, let's say F, and angle C is congruent to angle D, then we can make something called a congruency statement. And we would say that triangle A, B, C is congruent. Remember, this is the symbol for congruence, the equal sign with the little squiggly on top. Okay, is congruent to triangle. And then this has to match up. So if I'm talking about A first, this angle with the one slash right here has to match up with this angle with the one slash. So we're going to say E. B is the one with two slashes, so we need this one with two slashes. So we're going to go F, and then the last one would be D. Okay, those are in order of each other. So angle A is the same as E. We're saying that those two are congruent. B is the same as F, and C is the same as D. Okay. We can claim that, or we can write these out too. So if we're going to say that all these angles are the same, we'd say angle A congruent to angle E. And this is the symbol we use for angle, it looks like the less than sign. Okay. Angle B is congruent to angle F, and angle C is congruent to angle D. And we could tell that even if we were just looking at this congruency statement because they are in order of which ones are congruent to which. Okay. Let's also write some congruency statements about the side lengths. So side length AB, so if we're looking at AB here, that's going to be congruent to EF. So we're not going to switch AB and then make it FE. AB and then EF are the same. So we would say side length AB is congruent to side length EF. It's that one and that one. And they're both the sides with theirs that's attached to the one with the one slash angle and the two in between the one and the two here. Okay. Next one, let me erase this. We'd have side BC is congruent to FD. So write BC congruent to FD. And you can even think about it as if we're, instead of saying CB, if we're doing BC, then we're going from the angle that has two slashes to the angle with three slashes when we're naming it. So down this way. Okay, so if we're going to do the same thing here, we're going from the one with two slashes to the one with three slashes. So we would call that one FD. That's what we have here. Okay, and then the last one, they're not right next to each other in the, sorry, um, in this statement of the triangle. So we would say AC, that's going to be congruent to ED. And we can think about it the same way if we're going from the angle with 1 to 3. We're going to call that one AC. I'm going to write it up here. And that's congruent to this one. If we're going from 1 to 3, it'd be ED. Okay. And these are what we would refer to as the corresponding parts of the triangle, these side lengths here, as well as these angles. So we'd say angle A corresponds with angle E in the other triangle. And side AC corresponds with side ED in the other triangle. Okay, and this is what, down here is what we call a congruency statement. So if you're asked to do that on the test to write a congruency statement, you're writing triangle, whatever letters it gives you is congruent to EFD, and order does matter. So make sure that the corresponding parts of the triangle are matched up the way that they should be, like how we just discussed. Okay. We're not delving into proofs right now, but there is a very important phrase that we use when talking about congruent triangles. And it's corresponding parts of congruent triangles are congruent. So if we're saying that both of the triangles are congruent, then each part that it matches up with would also be congruent. Remember, congruent means has the same measure. So if we're talking about angle, same angle measure. If we're talking about side length, same side length measure. And there's an acronym that's used very often. It's called CPCTC, and its corresponding parts of congruent triangles are congruent. And it's just shortened to CPCTC. So if we were to do a proof, this is like what your end statement would be. CPCTC. Okay, we're not doing proofs this year. You're supposed to be, but next year you're going to start with geometric proofs, and this is an important phrase to know. So I wanted you to be aware of that. Okay, the next thing is vertical angles. So we're going to go into the triangle congruence theorems. That's the SSS, SAS, ASA, all of those ones. This one might look like it doesn't have enough information, and this probably came up in an example we've already talked about, but I wanted to make sure that it was clear that this is a property that we can rely on. So far it only looks like we have one matching angle and one matching side. So we have angle B is congruent to angle D, and side length, we're going to call that, this is C in the middle. Side length BC is congruent to side length DC. So we have those two pieces of information. There's a very important other piece of information, and that's this angle right here. So these angles in the center are also congruent to each other, even though they weren't marked that way. And that's because of something called vertical angles. If you have two lines that cross kind of like an X, the angles opposite of each other are always congruent. They're always the same measure as each other. So those would be congruent to each other, and even though we don't normally need this part, these would also be congruent. Just the opposite, so vertical angles, they're congruent to each other. So we are going to claim that angle, let's call it BCA, is congruent to angle DCE. And notice I kind of called them two different things here. Angle B, it's a little bit clear which one angle B is. But if I only said here, angle C, because that's where the C point was, right here. Sorry, I'm just trying to show you. I can't see my finger where I'm pointing. I would call those both angle C, and that's super unclear which side of the triangles I'm talking about, so I wanted to be more specific on that one. But we can say that that is by vertical angles. So if I ever see something with, sorry, like that, those obviously aren't congruent because I can't draw straight, but like this angle and this angle that are opposite of each other would be the same measurement. So that is something that you can infer whenever you see that on a problem, on a test, or a homework assignment. Okay. So this one, just so we're reviewing, we would claim that these two triangles are congruent by the angle side angle theorem. Okay, because we have this angle and this angle, and we have a side directly in the middle. So it'd be angle, side, angle for that one. Okay, it won't always be angle, side, angle anytime you have vertical angles, but it's something important to note. Okay. This last little piece is about something called alternate interior angles. So with the amount of markings that are already on these two triangles, they're kind of like stacked together right now. We have all the pieces of information we need, and it might not look like it. So these arrows right here, these mean that these lines are parallel. So if you ever see little arrows like that on lines that look parallel, it's saying that these are absolutely parallel. It's confirming that information. Sorry, my blood sugar. Um, and what this tells us is that the angles that are opposite of this line, so this, let me see, where are my colors? Wait, hold up. Okay. I was gonna switch colors. It's not gonna happen right now. Okay. But this line right here is kind of cutting this. It looks like a parallelogram right now. It's kind of cutting it in half along the diagonal. And we can claim that this angle right here is the same as this one. So notice how I'm pointing at the opposite sided one. So this one and this one. Those are the same measurements. Okay. And that's why we call them alternate, because they're like kind of alternating which side they're on. So those are the same length, or sorry, same measurement. And then the ones here, so if I look at this one here, that's also the same as this one here. Again, notice that they're on opposite sides of the triangle. This is because of alternate interior angles. It's a property that is just known in geometry, and I'm either reminding you of it or you're learning it for the first time. But if you have two parallel lines and there's something kind of cutting it, we call it a transversal. That's not a word you need to know for this test, but a transversal is cutting it like it is here. Then the all opposite angles are gonna be the same. Okay. And then hopefully it's obvious. If not, now we know that this middle line is the same as itself. AC is congruent to AC. And that's something called the reflexive property. So I wrote it down here already. Reflexive property. And that just means something is the same as itself, and it's something that sometimes we need to claim, even though it's obvious. So side AC is the same as side AC, is basically what we're going for. If we're going to write out the other congruency statements, angle BAC, so I went with the one that has the two lines. So remember BAC. Oh gosh. Undo. Not that. Undo. Okay. BAC is going to be the same as DCA. Remember that angle that you're talking about? So we're talking about C. That's got to be in the middle with the DCA. Excuse me. And then we're going to have angle BCA. So remember, C is in the middle this time for this one. BCA is the same as DAC. So now with the information we have, we can claim that these two triangles are congruent by this is another example of angle, side, angle. Okay, because we have one side in the middle of two angles that are congruent. So those are just a couple of properties that I wanted to go over that maybe I wasn't clear enough before on the previous test. Not test, video, sorry. But yeah, that's about all you guys need to know. Make sure you're studying or taking notes, you're doing what you need to do. Okay? All right, I'll see you guys later. Bye.